you have two different things happening at the same time when it comes to movement. When it comes to the whatever the object is. So number 31. 31 says a particle's acceleration changes from 2 meters per second squared to 4 meters per second squared after 3 seconds. If the initial velocity was 10 meters per second, what is the final velocity after 6 seconds? All right, so you have two intervals that are taking place here. Okay? Two intervals. The first of which is 2 meters per second to 4 meters per second. Okay, so you have an initial 3 seconds. Interval 1 is from 0 to 3 seconds. Okay, and then interval 2 is 3 to 6 seconds. All right, so we break this down. Just gonna write on here now. Do I have to? If I do this. Okay. So in this case, so you have it changes from 2 meters per second to 4 meters per second. That's going to be your acceleration, okay? And 3 seconds. The initial velocity is 10 meters per second. Okay? So let me do this. 2 meters per second. That's going to be 3 seconds. And 10 meters per second. All right? So that tells you those are going to be the ones that you need to use on that. I guess we can do this way. So particle's acceleration changes. It's moving this way. Acceleration is positive. Displacement is positive. Moving this way. Okay, so it starts at the initial velocity of 10 meters per second. The acceleration for the first part, the first interval, is 2 meters per second squared. And your time is 3 seconds. I swear to God, if you don't get out whatever you're eating, just take it out. Be done with the sounds. All right? So you have the time being 3 seconds. So now you can do your kinematic chart with your variables. VI, VF, A, T, D. Okay? What's your initial velocity?
0.
10 meters per second. Okay? Do you have a final velocity yet? No, but it's something that you need to solve for. Okay, so that's what you're going to be solving for. What's the acceleration? 2 meters per second squared. What's the time? 3 seconds. Because that's your first interval is 3 seconds, right? So do you need displacement? No, you don't. Okay, so to solve for what the final velocity is in the first interval, its final velocity equals initial velocity plus acceleration times time. Final velocity is 16 meters per second. Okay? So that's your interval 1. That's interval 1. Right? Now, interval 2. Interval 2 is, what's your time? What's your time for interval 2? 3 seconds. So VI, VF, A, T, D. 3 seconds.
Do you have to write another chart?
Yeah, you got to do a second one because there's a second set of motion. Okay? So 3 seconds, because the final velocity total was 6. So 6 minus 3 equals T2, or interval 2's time, which is 3 seconds. Okay? What's your initial velocity?
16.
16, because it's what you've determined it to be. Okay? Because the acceleration changed. So it's 16 meters per second. Do we know the final velocity yet? No, we don't. We need to solve for that. Okay? Do we have acceleration? What is it?
2.
It's 2 meters per second. No, I'm sorry, 4 meters per second. It's 4 meters per second, because it's ultimately, it's what you ended with. So it's 4 meters per second squared. All right, so now, what do you have to figure out? What's the final velocity? So the final velocity for that is going to be, do the same equation. VF equals VI plus A times T. Okay, so VF, that's what we're solving for. VI is 16 plus 4 times 3. So it's 16 plus 12. Your final velocity is 28 meters per second. So the final velocity after 6 seconds is going to be 28 meters per second. Questions?
How'd you get the 4?
Right here. The acceleration changes from 2 meters per second to 4 meters per second. All right? So is 28 meters per second the final velocity?
Yeah.
Is it?
No, it's not.
Is it?
Yes.
Is it?
This is a trick question.
Why, if it isn't, why wouldn't it be? Why wouldn't it be? Or if it is, why would it be?
You don't know the distance.
Doesn't matter. Let's try that. So what do we know? Okay. Is it,
Oh, it's not.
why would it not be? If you think, I'm just asking the question because I'm going to be honest with you, this is one of those things that you need to think about. Is it or is it not? Why would we say that it's not?
Because it says initial velocity after 6 seconds.
Okay, maybe.
I mean, I would be done after this point.
Do you have to do more?
No, you don't. It is the final answer. Why is it the final answer though?
That's what we got when we did the equation.
Okay, it's not because it's what we got.
It's
As much as I would love for that to be the answer, that is not the answer. Why?
because they're both.
Because they're both in the intervals, but why is this the final answer? Because you've taken this from here. You've taken the speed, the final speed of interval 1 becomes the initial speed in interval 2. So therefore you don't add them together. Okay, when it comes to the speed part. When we get into a couple of the other questions where you have to figure out the distance, then you do have to add the distances together. Okay, does that make sense? Okay. All right. So 32 is a perfect one. So let's do this. And let's do this. All right, so number 32. 32 is a rocket accelerates. Rocket accelerates from 0 to 100 meters per second over 20 seconds with variable acceleration. if it maintains an average acceleration of 5 meters per second squared, what's the displacement? Well, okay, so are there two different kinds of movement here? No, it just goes from start to end, right? So you have a rocket that starts at 0 meters per second. The acceleration's positive, the displacement's positive, okay? And it gets to 100 meters per second. And the average is about 5 meters per second squared, okay? So this really looks like kind of like a regular problem, and it is. So how would you solve for this? I would use D equals 1/2 of VF plus VI times T. Okay, so D equals 1/2 of 100 plus 0. I forgot to do the chart, sorry. Bless you. VI, VF, A, T, D, 0, 100. Acceleration, we do not know. Time is, oh yeah, we do know acceleration, sorry. 5 meters per second squared. And the time is 20 seconds. And we're solving for displacement, okay? So final velocity 0 plus 100, 1/2 of that times T. So what's 1/2 of 100? 50 times 20. What does D equal? It's 1,000 meters. A positive 1,000 meters. Okay, or you could say 1,000 meters to the right. Okay? You're done. 32 is done. There's nothing else you need to do here. Okay, because you figured out, it tells you that the average acceleration is 5 meters per second. That doesn't mean it stays constant. It's just different. It doesn't, when you add all the numbers together, the average acceleration is 5 meters per second squared. So that way you can use it. Okay, so 33, again, we're dealing with intervals. Okay, so you have a vehicle that moves at 15 meters per second and accelerates at 3 meters per second squared for 3 seconds. Then accelerates further at 6 meters per second squared for 2 more seconds. What's the final velocity? All right, so what are the intervals? Interval 1. So interval 1, what's the timing? From when to when? I know, I'm bored too.
3.
0 to 3, that's interval 1. 0 seconds to 3 seconds. Good, Rayleigh. What's interval 2?
3 to 6.
Yes. Interval number 2 is 3 to 6. So what does this tell you? What do you get? How many charts are you gonna have to make? 2. You have to make 2 charts. All right. So in this case, here's your car. Whatever. It's moving at 15 meters per second, and it's accelerating. Acceleration, positive. Bless you. It accelerates at 3 meters per second squared. Okay?
Wait, wouldn't interval 2 just be 5 seconds? Because it says only for 2 more seconds.
So it would be 3 to 5, yes, sorry. Good spot. 3 to 5 seconds. All right, so you don't know the final velocity. You don't know displacement, but you just need to solve for final velocity. So it starts at 15 meters per second. It goes for 3 seconds, and it's accelerating at 3 meters per second squared. So when we do our box for interval 1. VI, VF, A, T, D. What's the initial velocity? Good, 15 meters per second. Final velocity? Solving for it. Acceleration? 3 meters per second squared. Time? 3 seconds. Displacement? And don't need it. Okay, because you're not being asked for velocity or for displacement. So you have VI, you have A, you have T. You're solving for VF. First equation. VF equals VI plus A times T. Okay? VF is what you're solving for, equals 15 plus 3 times 3. VF equals 15 plus 6. Nope. 29. Sorry, it's 9. Sorry. 24 meters per second. Okay, so that's your final velocity of interval 1. 24 meters per second. Okay? So, interval 2. What are we going to do? So we got to do another chart. For interval 2. VI, VF, A, T, D. So what's the initial velocity for interval 2? Exactly, it's the final velocity of the first interval. So this is 24 meters per second. Do we know the final velocity? No. No, we're solving for that. What is the acceleration?
6.
It is 6 meters per second squared. What is the interval of time, or what's the time of interval 2?
2 seconds. 2 seconds.
2. 2 seconds. Displacement doesn't matter.
Because it
For
was-
2 more seconds.
Oh.
All right. So again, what are we solving for? What's it asking for? It's asking for what is the final velocity. All right, well, we just do the same equation again. VF equals VI plus A times T. VF equals 24 meters per second plus 6 times 2. It's 24 plus 12. So your final velocity is going to be 36 meters per second. So your final velocity after all this is 36 meters per second. So what you have to do is you have to pay attention in the problem itself and see if there is any change in velocity. Okay, if there's change in velocity, that means there's going to be intervals. And with those intervals, you have to do each interval to be able to get to what the final answer is. Okay, so let's do 36. So number 36. A race car accelerates at 8 meters per second squared for 6 seconds. Then maintains constant speed for 10 seconds. Then decelerates at 5 meters per second squared to a stop. What is the total distance traveled? Okay, so let's look at this question. Okay, we have a race car accelerates for 8 meters per second squared for 6 seconds. Then it maintains a constant speed for another 10 seconds. Then it decelerates at 5 meters per second squared to a stop. What's the total distance traveled? How many intervals do we have? 3 of them. You have 3 separate intervals. You have the acceleration piece. It maintains its constant speed. then decelerates at the end, okay? So you have the three separate intervals: acceleration, constant, decelerate. Okay, God bless. All right, so let's look at this. Race car accelerates. And it's going to be starting from rest, okay? At 8 meters per second squared for 6 seconds. Okay, so it accelerates. We don't know what the final velocity is. We just know that the acceleration is positive and it's 8 meters per second squared. The displacement's also going to be positive. Okay, so let's do our first chart. So VI, VF, A, T, D. And remember, there's 3 intervals. They are the acceleration, constant, and decel. Okay, and acceleration, the first one is 6 seconds, so it's 0 to 6. Okay, and your initial velocity is 0 meters per second. Final velocity, we don't know. It's accelerating at 8 meters per second squared. And for how long? 6 seconds. In the end, what are we trying to determine? We need to determine just this travel. However, do we have to find the final velocity?
No. Yeah. Yes.
You do. Why? For the other intervals. Okay? So you do have to find final velocity. So let's just find that real quick. VI plus A times T. VF equals 0, cancels AT. 8 times 6. So your final velocity of interval 1 is 48 meters per second. Okay? And D1 is going to equal, why am I drawing a blank? 0.5 times VF plus VI times T. Okay? D1 equals 1/2 of 48, which is 24 times 6. Finding distance for D1. All right? So this is 144 meters. A positive 144 meters. So that's your D1. Your constant maintains a constant speed for 10 seconds. Okay? So this interval is 10 seconds. And if we draw this one for interval 2, what's your initial velocity for interval 2? 48 meters per second. What's your final velocity? It's 48. What's your acceleration? It's 0 because it's constant. Okay, and your time is 10 seconds. Okay, so now you do the same thing. D2 equals 0.5 VF plus VI times T. Okay, so D2 is 48, and 48 is 96, but you already know it's going to be 48 times 10. So D2 is 480 meters, positive. Okay, so that's your displacement for D2. D3, what's happening in this one? It's decelerating. Okay, we don't know what the time is. We don't know what the time is, but we know it's a third interval. Okay, so what is its initial velocity? What's the initial velocity for interval 3? Yep, still at 48. What's the final velocity? Yeah, because it's coming to a stop. Acceleration, -5, right? meters per second squared, the time, and the D. Okay? Can we determine distance without time? No,
No.
we cannot. All right? So we're going to go VF equals VI plus AT to get time. 0 equals 48 minus 5T. Subtract 48 from both sides. Divide by -5. And your time is going to be 7, 8, 9, 9.4.
What's the acceleration for the box?
-5. Decelerates at 5 meters per second squared. So it's negative. All right. So your time is is it not, what's 48 divided by 5?
8. No, it's
9.
It's 9 something. What is it?
It's 9.
48 divided by 5.
9.2.
It's 9.6, right? Okay. So it's 9.6. So it's 9.6 seconds, and it's a positive 9.6 seconds. So it's 9.6 seconds. Now you can solve for distance. Okay? So the distance in interval 3 is half of 48, which is 24, times 9.6. And D is going to equal 24 times 9.6 is... Thanks. Thanks, Becky. You've been a big help. 24 times 9.6 is...
30.4.
Yes, that is correct. Go ahead, Joe.
When in the last one, when you're doing the VF equals DI thing, I'm confused on that.
Hold on. Let me just do this first. So this is going to equal 230.4 meters, and it's a positive. Joe, ask that question again, bud.
On the VF equals VI.
In interval 2?
No, the bottom one.
Oh, interval 3. Okay.
Yeah, I'm confused.
So VF, it's coming to a stop. So the final velocity is going to be 0. VI is 48. It's still at 48 meters per second. Okay. The acceleration is negative. Anytime you see deceleration, it's going to be a negative acceleration because it's slowing down. So it's a -5 meters per second squared. To be able to get displacement, we have to solve for time first. So when we do that, we get 9.6 seconds. Talk to me.
I know.
You see it now?
Yeah.
Okay. All right. So then once we have our time, then we can again go back to D equals VF plus VI times 1/2 times time. Well, 48 plus 0 is 48. Half of 48 is 24. Your time was 9.6 seconds. So your D3 is 230.4 meters. So what's the total displacement? We have to add them all together. You add D1 plus D2 plus D3. So it's going to be 144 plus 480 plus 230.4. And when you add it all up, 6, 7, should be 854.4 meters. That's your total displacement. It's a positive 854.4. Questions? When there's a change in velocity, you have to set it up as intervals. You have to do the first part, second part, third part if there's 3, fourth part if there's 4, whatever. All right? So just in 39, if we were looking at 39, a cyclist decelerates from 20 meters per second to a stop over 200 meters. Okay, so let's look at the intervals. Let's just come up with what the intervals are. So a cyclist decelerates from 20 meters per second to a stop. That's interval 1. Interval 2, then rests for 5 seconds. And then interval 3, then accelerates again at 3 meters per second squared. Okay, so in terms of that, again, you have 3 separate changes. You have deceleration in the beginning. Okay, you have a resting period, which if you look at this, you have to figure out how far does the cyclist travel. Do you even have to do anything for the second interval? No, why? What are you solving for?
Distance travel.
Right, you're solving for distance traveled, and if he's at rest, what's the distance?
0.
It's going to be 0. Okay, so keep that in mind as you're doing this, and then it accelerates again. So at that point, you need to figure out, okay, what's going to be the final velocity? The final velocity is going to be, you're starting from rest. The final velocity is going to be 20 meters per second, because that's what he got up to in the first part. All right, questions? Good?
Yeah.
Okay, so now I expect it to be done. It's the weekend, Tuesday. All right.